So for me, it actually started in aviation. Before I got into aerospace, going all the way back to the beginning, I was the most interested in aviation, both commercial and military. I would go and sit near airports. My mom would take me to go watch airplanes. We would go sit by the runway. And I think when I was probably, by the time I was probably 6 or 7, I could pretty reliably identify every type of aircraft. There was also an air base near us. This was when we lived in upstate New York. And yeah, so I really wanted to be a pilot someday. It was pretty much all I could think about. As I got older, I started to have more of an interest in aerospace. In high school, I wanted to be a mathematics major. In college, I wanted to do math research. Very academic. Briefly, I thought about physics. Really did not want to go into engineering just because it seemed like there was all this pressure to go into engineering, and I don't know. I spent a lot of time just watching number file videos on YouTube and these British mathematicians exploring these weird boundary problems in math, and so I kind of arrived at engineering in this roundabout way where I was interested in aerospace as a young kid, but then I was less so interested in it as a teenager, and then more when I went to college, it became interested again. I went down to go see the Demo 2 launch in Florida. I flew down with my friend to go watch, because I knew this would be the first time that the Americans launched astronauts into space in a very long time.
Reports say all systems are go. Vehicle is supersonic. We've exceeded Mach 1 on the Falcon 9.
And 1D throttle up.
We're throttling back up to full power.
Seeing that rocket go up, it was a Falcon 9, and knowing that there were people on board, I feel like is really what sparked my passion for human spaceflight. Seeing the rocket go up and realizing in that moment sort of how much was at stake, and I felt like it was a glimpse into the future of our species. So that was a very big moment for me. And I think that moment played a super big role in me eventually going there to actually work on that program. In grad school, I was doing research on an area of applied graph theory called network science, which deals with large systems of interconnected entities and emergent properties from them. So the property in particular that I was doing research on is this concept of centrality. So these are these are common ideas that you can apply to many different domains. So an example of a network could be you're looking at the a pathogen network of how a disease was spread, and you're doing tracing. It could be a social network online. It could be a computer network, so literally network topology. And in many different domains, it's valuable to identify which parts of the network are important. So how important a given part of the network is. And there's different ways to measure this. There's ways to measure it. There's discrete algorithms in computer science that can do it by doing things such as measuring, very, very rudimentary ones, like what's the degree of a node, which is just the number of other nodes that it's immediately connected to, very, very surface level, all the way to things that are more sophisticated, like let's look at every single pair of nodes in the network and compute the shortest path between them. And let's look at all the shortest paths and figure out how many of those shortest paths go through this node. And that's how we can determine how important it is. I was finishing up my master's degree. I was writing my thesis, and I knew that I wanted to work at a really cutting-edge tech company. And I applied for a number of different companies, but at this point, I was so excited about SpaceX, so much more than any other company. I think there were a few others at that time, just some of the big tech companies that I did feel strongly about, but SpaceX for sure was number one, and I had no connections whatsoever. Nobody from my college had ever worked there, so it was hard for me to network, but ultimately I ended up just applying on the website. It was just as random as that. I applied on the SpaceX website for a software engineer position. I refined my portfolio, my resume as best as I could, but I sent it away, and just like a lot of these companies, you just kind of send it away and then you expect nothing to ever happen. But in this case, I received a phone call from this California area code like 24 hours after I did it, and it was this recruiter from SpaceX, and this was back in October or November, and he was basically asking if I'd be willing to apply and go through the process and interview to start working immediately, which I had been, I was like a year into my master's degree already. I was writing this thesis. I had done a ton of research, and my advisor and my research lab had poured a whole bunch of resources into me, and they had given me a bunch of funding, and it felt a bit abrupt to just sort of leave all of that behind. And so I told him that that it was too early for me, and that I was going to stay and finish writing my thesis and publish, and that we could be in touch, the following summer. Which, after I did this, I definitely had a lot of doubt. Like, shoot, maybe I just sort of like missed a big opportunity, and that weighed on me a bit. So, but yeah, I just kind of focused on my work and my research, and a number of months went by, and then in the spring, I wrote this sort of very, very carefully worded email, kind of designed to get through the filter and not just get thrown away by this recruiter who I'm sure is bombarded with all sorts of candidates. The first interview was like a 2 or 3 hour technical coding interview, and it was this timed interview where it was kind of your typical leak code hard style questions, where each one you have a sort of big time allowance, sort of like, it was maybe four questions with 45 minutes each, I think. And at the time I was living in this like fraternity annex house where we were having parties, and we actually had this massive like house party. It was like a Saturday afternoon, and I was up in my room taking this test, and you had like people coming up to my room, like handing me drinks, like trying to get me to drink, and I'm like, get out of here, I'm doing this thing. Because through this whole process, I didn't tell anybody I was applying there, because I felt like if I started telling people that I was going through this process, then somehow I would be more impacted by other people's perception of the company, or I just wanted to close out all external influence and sort of, just lock in and focus. I had a phone call with one of the lead engineers in this org. This was actually prior to the technical, where we just talked about, my experience, and I got to ask a lot of questions, and it was pretty technical, but it was just a phone call, and that was really good. I think that was the first time that I got a perspective for the caliber of the people there, because this random person who I had never heard of and never really spoke to again after that was just incredibly smart and detailed with everything that they described, and I think that was where I first started to understand the caliber of the engineers there. And I did the coding test, which went pretty well, and then there was the final round, which was this was during COVID, so I didn't fly out to do it in person. It was completely virtual, and it was like a 4-hour interview where you would have like a 45-minute interview, and then there'd be 15 minutes where they would kind of discuss internally, and you would get out of the Zoom call, and then they would basically call you to tell you whether or not they were proceeding to the next one or not, because SpaceX is like incredibly time efficient with people. So halfway through, if they realize it's a no, they'll end it early. The final hour was I had to present a project that I had done. I think this was really kind of the selling point for me, and the reason why I got into SpaceX was because of this project that I presented. It was this mobile app that I had created in college just for fun, and I had sort of been primed a little bit by the recruiter ahead of time and told that talk about things at an extreme level of technical depth and don't gloss any over details, don't abstract anything. Be prepared to go into depth on anything that you bring up, you're going to get grilled about. So I joined the call, and there were about 10 engineers on the call that I was presenting to. And I did this 1 hour presentation with slides, and I still have the slideshow, actually. I've gone back and looked at it a few times for the memories. But it was good, and it was exactly as the recruiter told me. They grilled me on everything, and wasn't really sure how it went, but yeah, had a great time. And literally the same day after I was done with that, I went home. I was like, okay, I got that off my chest. I did the whole process. Now I can just move on with my life because I know I did it. I got a call the same day that evening telling me that I got the job. And it just felt completely unreal because it was like, I did not expect it at all to happen. My first day at SpaceX was pretty interesting. I came into work like just really, really amazed by this whole facility and this campus that they had put together. It's this like collection of buildings where it's like rockets are getting like put together in one building, the engines are getting built in this other building, and they're kind of like there's these carts and they'll move them between the buildings. And it's this whole like little city block where all these buildings are SpaceX and they're building various things. You know, the ion thrusters for the satellites or the Dragon capsule for the astronauts. And coming on my first day, I feel like I saw that right away, where there was just all these different related projects that were all kind of happening in one place. And that was just amazing to see. I remember I came in my first day, I went in the front door, and there's like this orientation room where I had orientation with the other 20 people that were starting that day, and it was very surreal. The whole thing was very surreal. Like, I don't even remember what they talked about, because it was just like, I just remember kind of just being, in awe of the whole thing. You know, I was part of application software when I was there, and I worked on a couple different projects. Like I worked on manufacturing software, so it was like shop floor. I moved into supply chain, so I was doing, actually I wrote sort of like the replacement MRP engine, which is in charge of doing resource allocation, so kind of deciding which rocket parts go where, and backward scheduling from the launch date and figuring out when we need certain things, sort of like a giant complex Gantt chart using a bill of materials that has like a million different part numbers. It's a big computational problem, which was a really cool problem domain, and there was like a big need for it, so I'm glad I worked on it. But ultimately, supply chain wasn't just the most compelling thing for me, and I wanted to get a little bit closer to the more, I guess, unique problem sets, I think, for space. So then I went to go work on the telemetry system that we had there, and that system was super cool because it was operating at a scale that I hadn't really seen before. It was processing all the data from the Starlink constellation, and it was actively being expanded to be used for Starship too. And I got to work on one little tiny corner of that system and just make it a tiny bit better, which was really cool for me. But ultimately, the bigger the scale, the bigger the impact of the platform, it felt like the slower that the project moved. And so it was it took longer to make changes because it was just, everything was more critical and it directly impacted launches. And that was honestly not what I expected it to be. I was looking for something that was as fast-paced as sort of like the manufacturing side of SpaceX is just like hardcore, like super fast-paced, like super chaotic, like everything's always changing, super rapid prototyping of different ideas in manufacturing, because SpaceX really is a manufacturing company at the end of the day. That's what they do. They manufacture rockets quicker and better than anyone else. And I was kind of hoping that it would be that same work style when I was working on sort of the big data telemetry stuff, but it just wasn't. It was very different. It wasn't what I was looking for, and although it was a really good experience, I decided to move on. But yeah, it gave me a lot of perspective. I think if I had to go back now, which part, what part of SpaceX is the coolest, in my opinion now? Yeah, I think if you like to work on low-level stuff, I think the flight software team is really cool because, I mean, a lot of SpaceX is so big now that a lot of it's proprietary. So the transmission protocols, yeah, a lot of it is proprietary. There's unique and internal formats for how they transmit the data from the rocket. And the flight software has this counterpart called the ground software. They do like the launch pad is, a lot of people don't know this, but the launch pad is equally complex as the rocket because until that T0 when the rocket launches and actually lifts off, the pad is connected to the rocket and is sort of doing all the last minute computations and is sort of the life support for the rocket. It's keeping the propellants cryogenic. It's very, very complex and sophisticated, and then it just sort of at the last moment releases the rocket and just kind of lets it all play out. There was one time I was there where there was going to be there was a Falcon 9 launch. It was an uncrewed launch. It was an Arabsat, I think. I forget. It was a satellite launch, and we had some meetings, and basically we kind of like snuck out of one of the meetings earlier in the day so that we could get really, really close to, this one was launching from 39B, so we could get super close before they set up like the road barricades. This is even within the base. When you're at the Cape Canaveral base, it's so big, it's so vast that just like getting inside the base, which is not open to the public, you still have to drive for like an hour to get across to a different part of the base. It's really just that big and that vast. And we just wanted to get as close as possible as we could to 39B to watch this launch, because the closest I'd ever seen a rocket launch from was kind of where you can view from the public, which is more like 8 miles away. And so we got out of the meeting early and we drove to this payload prep facility, which is like, it was about a mile or so from the launch pad, 1 mile. And we set up and we could just like see the rocket right there on the pad. It was just like right there, like it was so close. I was actually like a little nervous Googling like, how close can you be like with the sound? Like, is it safe? And I read these stories of like in the Soviet Union, how like people would just be like super, super close and the sound would like kill them. And I was like a little nervous, but yeah, we we had these rental cars and just like found this parking lot, and we went early, so it was kind of like the whole area was closed off. But yeah, we were there and everything happened like right on time. And the thing that surprised me most, like when it lifted off, was not the sound, because that's what I was nervous about, was that it was going to be too loud, but it was the brightness. Like the brightness of the flame is like nothing you've ever seen before. It's like brighter than the sun, and you can't look at it because if you try looking at the flame directly, it's like you close your eyes and you still see it. You know how it like burns your eyes a little bit, and that totally caught me by surprise. That was pretty early on in my time at SpaceX, and that was at the time the coolest rocket launch I ever saw. It wasn't until about a year after that I saw the Starship orbital attempt, which, even though I was like way further away from it, it blew it out of the water. The Starship is like a whole different, that's a whole different beast. The overall quest to go back to the moon, it's been very, very long time since humans have been to the moon. Many people would say there hasn't been a reason to go, but we're so much more advanced technologically than we were the last time we were there, that there's new things, that there's the chances for us to demonstrate new technologies. The capability for humans to have a presence on the moon, I think, is important for proving that we can do it much further away, because the grand scheme of things, the moon is really not that far away. You can get there in a couple days. So I do think it's important that we go there as sort of a proof of concept, and it's a chance to demonstrate the technology and the ability of humans to live on the surface, which they've never done before. All the excursions to the moon were pretty short-lived. There weren't any lasting structures that were put there. Another experience I had that was super cool was getting to go to McGregor, which is the engine testing facility in Texas. I only got to visit there once, and I got to watch the testing of a Raptor engine and just sort of be super close. I was in the control room during the test, and just to feel the ground like shaking from the engine, it was super, super cool. And on that trip, I got to learn a little bit more about how the Raptors actually work, and sort of the difference between like the advancements they've made in the full flow combustion. I find the way that the throttle of those engines is controlled and any like full flow combustion engine is super interesting. The way that they'll sort of have they'll have two turbo pumps which are in charge of one will pump in the fuel and the other will pump in the oxidizer, and they're sort of mixing together. And one of them is running sort of fuel rich and the other is running oxygen rich, and there's sort of these like the symmetry of it is so beautiful, where one has an abundance of fuel and is throttling the speed by adding oxidizer, and the other one is doing the opposite. It has tons of oxidizer and it's just adding small amounts of fuel. And the way that the system is sort of symmetric like that and controlled, I think is super, super cool. It's actually you have the pre-burners for each of those two pumps, and then it's the outputs of those combustion. So it's actually all the unburnt fuel and oxidizer from those explosions that goes into the main chamber and is used for primary combustion. To me, that was just such like a crazy, twisted idea. The fact that this is happening, such an extreme pressures. I think when I was there, the record was 330 bar internal pressure, which was super, super high. It was hard to contain, but now I think they've done even more impressive things. They've made the engine even simpler and even stronger. Of course, the other really cool project at SpaceX that's super impactful now is Starlink. Starlink, there's like a number of advancements that have enabled SpaceX to do what they're doing with Starlink. The most obvious is the vertical integration with the launch segment. The fact that they're able to build their own rockets and launch them and launch their own satellites means that there's huge cost savings, where traditionally putting satellites in orbit is this very, very expensive ordeal. SpaceX was able to bring down the cost of this substantially, which sort of opens up a lot of new possibilities with communication satellites. So Starlink in particular, if you look at traditional satellite internet, like long before Starlink, you had satellites that were in a much, much higher orbit, which meant that the distance for the signals to travel, they would have to do a round trip from Earth to the satellite and back, would be a much longer path. So still instantaneous from sort of on the human perspective, but to a computer that's requesting some information across the internet, it's much, much longer. It makes things feel much slower. So what they did with Starlink is they did this vast constellation in the low Earth orbit, which means that the distance, it's very simple. The distance to Earth is just so much less, and so the latency is much less. And one of the reasons why, and it's my understanding that the low Earth orbit wasn't traditionally used a bunch in the past, is because satellites in low Earth orbit don't stay in orbit as long. They actually eventually, there's the upper parts of the atmosphere, there's small amounts of particles still, and they encounter some atmospheric friction over time, and they will eventually deorbit at a much faster rate than satellites in a higher orbit, which is just very unattractive if you spend that many millions of dollars to put something into orbit. So by making it cheaper, it makes it viable to place them in this lower orbit. When I was at SpaceX, the other really cool thing with Starlink was the laser link capability, which was just being rolled out. So oftentimes the optimal path for a data packet isn't to go straight from, well, I guess I'll talk about the old way of doing it. Traditionally, you'd have a single packet, which would go from, you'd have a user terminal, which is the Starlink dish that a person operates themselves. You'd have the satellite, and then you'd have what's called a ground station. And the ground station would be plugged into the fiber. Actually, it would have a direct link connection to the internet with a POP, point of presence. And so the a request over the internet might go from the user terminal to the satellite, back to the ground station, and then into the internet directly with fiber. But oftentimes, based on where someone is on the Earth, there might be a different optimal path to reach wherever it is that the request is heading for. So instead, the request can go to a satellite and be forwarded to a different satellite directly in orbit. And then and they do this by shooting photons at each other. They're using lasers to forward the request, and this sort of laser link between the satellites, because they're in these different orbital planes where sometimes they cross each other and they're close, and other times they're far apart. So at any given point in time, for a satellite, the other satellites that it can communicate with directly with lasers is constantly changing. And so it's this real-time, very complex, sophisticated system of like scheduling. It's a scheduling system of scheduling where the packets are going to go and what path they're going to take, and then retroactively looking at did they take the most optimal path, which ones were lost, at a given point in time, which satellites were communicating with which other ones. This was sort of the scheduling aspect of it was a team called the network topology team, and the team that I worked on was built the tools to do analytics on all the historical data we had. So being able to look back at a certain point in time and identify what happened. We sort of operated the databases and the query engine to analyze the data. So when I was there, it definitely felt like I was sort of part of this elite team of people that were solving this really cool problem, which was, to put it simply, making life multiplanetary, which is like a crazy mission for a single company to have, because it's something that is a quest for our species, according to some people. And yeah, and it was a very, very sharp, very driven group of people. A little cult-like. Like, I think everyone was everyone was so bought into this mission, where it was like every decision that was made in every meeting came down to like, is this going to get us to Mars faster or not? And if it is, then we do it. If it's not, we don't. And so it was like the mission was kind of in the forefront of everyone's mind every single day that we were there. And once you're there for long enough, then you kind of start to do it too. Like everyone around you sort of has this mentality, and it instills it in you also. One of the super notable experiences for me at SpaceX that was super impactful was getting to go to Cape Canaveral and actually go to Launch Pad 39A, which is the one where all the crewed missions, all the NASA missions, and now all the SpaceX missions, they've all gone from the same launch pad. And there's a crew access arm that the astronauts walk across, and they've been doing this ever since the Apollo mission. They've been doing it for decades. And there's this wall where the astronauts, right before they ingress, they sign their name on the outside. And so there's this wall of all these signatures of astronauts that have gone to space. And for me personally, probably my biggest dream in life is to go into space. So for me to actually get to not only to get to the base, but also to get to go up the tower, walk across the crew access arm, and like see this wall and this doorway where the astronauts went into the. It's something that's like not open to the public at all for any type of tour. That was just like, yeah, that was probably one of my favorite memories. Apollo astronauts walked across this crew access arm, and this was how they ingressed into back then it was Saturn V. Then you had many different generations of rockets, and they all went from this launch pad. And so this was sort of full circle for me, because just a couple years prior, I was standing like across the bay, 10 miles away, watching Demo 2 as just like a college student, just like a fan, with no affiliation to the company. And now a couple years later, I was literally on top of on top of the launch pad, walking across the tower, the crew access arm. And yeah, so that was like a big full circle moment. The other really cool thing was getting to go to Starbase. In the early days, I think when fewer people were going, it was we actually had a few company private jets that would fly directly from our office in Hawthorne to Starbase. And it was just like super quick, super efficient. We would just like walk over with our backpack and get on this plane. And it would just, in like 2 hours, would take us to the southern tip of Texas. And the company was always really supportive of people going to Starbase because that's kind of where like the next frontier of problems were being solved. And so even if you didn't have a super specific reason to be there, if your product or whatever your team was responsible for was being used there, you were encouraged to go there and talk to users and find out how to make it better and find out how to accelerate the Starship program. Starbase is like a totally unique place. It's like the people that live there, they are just the employees, the engineers, they are fully bought into SpaceX. It's like a SpaceX town. And it's actually a really cool place to go to. One of my favorite parts about working there was getting to travel there. One of the best memories I have of Starbase was getting to watch the first orbital attempt in person of the Starship, Super Heavy. And we were watching from, I remember I was there. We didn't know if it was going to happen or not because the launch window was always being moved around and it came down to weather and these other conditions. And we sort of had taken a gamble and we went down there thinking that it would happen. And it got scrubbed, which means it got pushed back by a few days. And it was sort of my last day there before I was going to come back. And we drove over to South Padre Island, and it was bright and early. It was like, I don't remember how early it was, maybe 8 a.m., 9 a.m. or something. And we went to South Padre Island, and we were watching from, I don't know, probably about the same distance that I watched the Falcon 9 from in Cape Canaveral, except this rocket is like an entirely different beast. It's like the largest, heaviest launch vehicle ever flown. And yeah, ended up launching it. And it was, I remember there was like maybe 45 seconds or so right after liftoff. It was just like burned, like etched into my memory. This launch was pretty rough, honestly. It was the first one. The rocket did not get very far. It did not get to stage separation. Yeah, I honestly, in my head, I had been thinking about this moment for years at this point. I'd already been there for a couple years. And so in my head, I was thinking this rocket is so big, so ambitious that part of me was thinking that it just wouldn't even get off the launch pad. It was just going to blow up, and it was just going to be super ugly. And to see the lighting sequence of all the Raptor engines, they start in this circular fashion. So there's sort of this sequence approach of how the engines start up, and it takes place over a couple seconds. So gradually you see all the engines start, and then to see this like massive, like 40-story building essentially just start to lift off. And after clearing the tower, there was already like several engines that were out. With my own eyes, I saw one of the Raptor engines explode. I saw like pieces of metal flying, and there was like, it was super chaotic, but it was overall, they maintained authority of the vehicle. And yeah, it was like, and the sound of it was just like, it was just a much deeper sound than the Falcon 9. What happened after SpaceX for me professionally, which was at the beginning I spoke about how passionate I was about aviation growing up, and how I think originally my real passion was for aircraft and less so for spacecraft. And I saw this content actually on LinkedIn talking about all the inefficiencies in air travel and how many billions of dollars this was costing every year. And really interesting, compelling arguments for just the need to modernize this stuff. And the big obstacle to doing this is not a hard technical barrier. It's the fact that operationally every airport works a little differently, and no one has been able to find sort of the best process, the best common denominator for how best to service an aircraft quickly. And different companies have tried different things to varying degrees of success, but it still remains one of the most operationally diverse industries. And I found this to be super interesting, and I just liked it. That's all I did. I just liked it, didn't comment, nothing. And the CEO of this company messaged me and said, "Hey, we're looking for a head of software. Do you want to interview?" And I said, "No, thanks. I'm good. I really, really love my current company. And you can tell how passionate I am about SpaceX and was then. So, yeah, I didn't really think about it. But he said, well, maybe we can just like tell you more about what we're doing, whatever. And so I had a phone call with them, which was pretty interesting. Got to learn about the problem, how they sort of started more so in hard tech, designing autonomous vehicles, and realized that there was this missing software layer, and decided to sort of do the soft tech first, and then transition into the hard tech. And yeah, I found the whole thing very, very interesting, and I sort of wanted to help these guys, but yeah, I really had no intention or desire of leaving SpaceX. But yeah, enough time went by, and eventually I decided to make the switch and go here, just because I really, really love working on a small team, and I love creating something new. As much as I loved SpaceX, after a couple years there, even SpaceX started to feel slow for me, where even the SpaceX style of finding a problem, proposing a design, and implementing it, and fixing it, and then maintaining it, doing this whole cycle in like a week that other big tech companies will take 2 months to accomplish, even this started to feel sort of, it started to feel like the problems themselves were still these small problems within a huge domain. And as much as I loved the mission of the company, I wanted to sort of go and create something new instead of solving small problems within a large domain. So currently Moonware is building a software ecosystem to automate ground field operations. So the reason that we do that is to improve efficiency on the airfield. It means that the aircraft can get what we call a turnaround, can be completed more quickly. So the aircraft can move on to its next flight more quickly, could reduce congestion on the ground and in the air. It can improve safety, visibility, and traceability too, to see what piece of equipment and what person worked on an aircraft where, because safety is a growing concern. The number of safety incidents are increasing every single year in aviation because the airports stay the same size, but the amount of air traffic is increasing every single year. And so there needs to be new innovative ways to solve these problems with the existing real estate that they have on the airfield, and this is a problem that hasn't really been solved yet. So this is the domain that Moonware operates in. It's starting with a software platform which tracks the live status of everything that happens on the airfield. It tracks the whereabouts of the people, the equipment, the aircraft, and gives a real-time view into what's happening. And it's proactive. So it identifies where things are, where the severity of different events. So it can actually predict ahead of time when something is probably going to go wrong, and when there's going to be a shortage, whether it's a crew shortage or equipment shortage, ahead of time, and it's able to notify people to actually fix the problem while they still have time, while the aircraft is still there. And then it's a historical audit tool too, so you can go back and see what happened. There's photos attached and multimedia, so you can, when these companies get audited and they have to prove that they have all their records in place for something, it's actually a centralized place that gives them all that data. Where traditionally that can be difficult. So Moonware is starting there, and then the plan is to transition more into autonomy and to do autonomous vehicles. The few companies that have tried to do autonomous vehicles on the airfield have had very, very little success because there's no infrastructure for commanding the vehicles. So ultimately what it comes down to is you end up, what these companies resort to is giving somebody a remote control, essentially. So it's kind of like a failed attempt at autonomy, where you can have vehicles that they may be driverless, but they're not capable of full autonomy because they're operating in an extremely complex domain of the airfield, where there's like very, very expensive assets. You have assets that are hundreds of millions of dollars that are rolling around. So it's very, very high stakes, and no one has been able to crack autonomy on the airfield. So that's the next domain that we want to get into, but we're kind of trying to solve the foundation layer first, which is the software. I have yet to find a different industry which is quite operationally, as I say, is quite as complex as aviation. And what I mean by that is you have a team, you have a plan for what you're going to do that day. And no matter how hard you try, no matter how good the team is at what they do, even when everything seems to happen exactly when it's supposed to, there are so many factors that just can't be planned for on the airfield. There's things that will take longer or take shorter, and there's things that are very, very hard to anticipate and predict. I'll give you a random example of this. So let's say you have a connecting passenger who doesn't make their connection. There's a law in the U.S. that says their corresponding checked luggage can't go on the plane. It's a safety issue in case they try to check in some kind of harmful device or something to the aircraft. So this is a completely random event where, as a result of a passenger in the terminal who, for whatever reason, they go the wrong way, they get lost, something, they don't make it to their connecting flight, the crew actually has to reopen the cargo door and find that person's bag and take it off, which is a completely unanticipated event, which can delay things. And there's probably about 1,000 different things like that can happen. And when this happens, it has these cascading schedule effects. So the people that have to do that now were otherwise supposed to work on something else. And there's this domino effect where it's the operation pretty much never runs according to plan, and minutes are worth thousands of dollars in this environment too. So it's extremely hectic and stressful. On top of that, you have people working in like crazy weather conditions, and you have, there's just so many different things that can go wrong. I think the hardest part about making efficiency gains in aviation is finding where the line is between things that are predictable, or as we like to say, games that you can win, versus things that we just have to accept the randomness and accept the chaos, and finding out a way to separate those two things. Because if you try to model the chaos and you try to predict the chaos, you'll fail. But if you find things that are predictable, like indicators that are reliable, for example, weather patterns may dictate a plane may have to go around at the last minute and add an additional 10 minutes before the crew can start doing work. That is something that is generally pretty predictable. Or if you look at the taxi patterns of the aircraft, you can see the taxiing might take longer than it normally does. But the example I gave where there's a passenger who misses their connection, in the long run, you can predict that these things do happen, but predicting where they're going to happen is probably impossible. So I think that's kind of fundamentally that's the hardest part about what we're doing, is finding out what we can model and what we can't. Advancements in technology that have this sort of like step function impact on humanity. So what I mean by that are advancements in the area of energy, clean water, and connectedness, like communication, connectedness. And I think the biggest step on that one easily was the internet and the advent of the internet and the globalization, the spread around the world of it. I think there's more advancements that could come. I mean, we're now seeing the proliferation of first, large language models. Now there's AI agents. I do think the large language models, both the first ones and the more recent ones, are very much glorified search engines, and they're extremely useful for searching information. And in some cases, you may search for something in a non-direct way, and it will figure out what you're really searching for and give you information. But there's a lot of problems that come with that, and I still think there's a big leap that we have to take from that to intrinsic reasoning. I don't think we're quite there yet. But nonetheless, there's been really impressive improvements lately. I'm excited for those improvements, but I think I'm more so excited for what I see as like these other areas that just haven't seen these big revolutionary changes in recent years. Like I said, I think energy is one of them, and probably clean water. Yeah, possibly advancements in processing, doing ocean desalination in a more sustainable or energy efficient way, generating solar power, figuring out how to build solar panels more inexpensively, potentially deploying solar panels in space at scale. I'm really excited to see how these things can actually can have a big impact on the quality of life for many people. I think the improvements we're seeing day by day with AI right now, I think is very much a hype bubble. The value is totally there. The value is totally there, and there's like the skeptics, and there's the people that are that's all they want to think about. All the companies that people want to fund right now related to AI. I think it's somewhere in between. I think it's like the dot-com bubble in the early days of the internet, where it was a little bit overhyped, and we're trying to figure out where it's actually going to land. But I am excited for the attention to kind of go back to other things, honestly. Some cases over here. Kind of see what they want to look like. The big one that we're gonna check is like, it's like pretty crazy looking.